Good morning and Pax at Bonum. Our lesson for today is Series Circuit Law. So to be discussed by yours truly, Mr. Arnel P. Manuel. Subject feature. According to series circuit law, the total resistance in series circuit is equivalent to R1 plus R2 plus R3 and so on. So it means that individual resistances inside the circuit is simply added to get the total resistance. How about the total voltage in series circuit? According to series circuit law, the total voltage in series circuit is divided into the number of loads inside the circuit, or it means that the total voltage in series circuit is equivalent to V1 plus V2 plus V3 and so on. So it means that the total voltage is divided into the number of loads inside the circuit. And then, for the total current inside the series circuit, IT, or the total current, is equivalent to I1, equivalent to I2, and equivalent to I3. It means that the total current in series circuit is everywhere equal, meaning everywhere in the circuit that you measure the amount of current is always equal to the current anywhere in the circuit. Let us have a sample computation of resistance in series circuit. We use the formula RT, or the total resistance, is equivalent to R1 plus R2 plus R3 and so on. Here is the given circuit. We have R1 equals to 3 ohms, R2 equals to 5 ohms, and R3 equals 2 ohms. Then, what's missing is the total resistance. So, so using the formula RT is equals to R1 plus R2 plus R3, we substitute the formula using the given on the given diagram for series circuit. So 3 ohms plus 5 ohms plus 2 ohms will give us the total resistance of 10 ohms. Now let us continue with the computation of voltage in series circuit. So using the formula Vt, or total voltage, is equivalent to V1 plus V2 plus V3. So again, we use the same circuit given a while ago for the total resistance in series circuit. So R1 is equivalent to 3 ohms, and R2 is equivalent to 5 ohms, R3 is equivalent to 2 ohms. With a given total voltage of 10 volts, how can we compute the individual voltage inside the circuit, the voltage drop at R1, voltage drop at R2, and voltage drop at R3? So to get the voltage drop at individual load, we need to get the current on each load. So to start with our computation, we need to look for the total current. Since total current is missing, we can use the formula in Ohm's law, wherein we can use the total resistance and the total voltage to compute for the total current. So we use the formula IT is equivalent to Vt over RT, or it's the same as the formula that we use in Ohm's law, that I is equivalent to V over R. since we are computing for the total current, we need to use the total voltage and the total resistance inside the circuit to solve for it. So our formula will be IT is equivalent to VT over RT. We substitute the formula 10 volts over 10 ohms and gives us a total current of 1 ampere. Now, since we now have total current of 1 ampere, we can now start solving for the individual voltage of each load. So, what is going to be our V1 or voltage at R1, voltage at R2, and voltage at R3? So we solve first for the V1 or V1, voltage drop at R1, using the formula I1 times R1 or V equals I times R. Okay, so since we are solving for individual voltage at load 1 or resistor 1, we can use the formula V1 is equivalent to I1 times R1. So since we have the value for R1, which is equivalent to 3 ohms, and we do not have a value for I1, so where are we going to get the value for I1? So since series circuit law, it says that IT is equivalent to I1, equivalent to I2, equivalent to I3, and so on. So we can say that the value of I1 is equivalent to 1 ampere. Since in series circuit law, IT is everywhere equal in the circuit. So therefore, at R1, it is still equivalent to 1 ampere. So we substitute the formula. I1 is equivalent to 1 ampere times 3 ohms. And it gives us total voltage of, for V1, is equivalent to 3 volts. Next, looking for V2, or the voltage drop at R2, our formula will be I2 times R2. So again, since IT is equivalent to I1, equivalent to I2, equivalent to I3, we can simply substitute the value of I2 to 1 ampere. So it gives us 1 ampere times 5 ohms, and it will give us V2 is equivalent to 5 volts. And lastly, solving for V3 will give us I3 times R3. So we substitute the value of I3 equivalent to I3, which is 1 ampere. So we substitute the formula, okay, and it will give us V3 is equivalent to 2 volts. Now, if we are to check if our uh, solution is correct, so basically, voltage in series circuit says that Vp is equivalent to V1 plus V2 plus V3 and so on. It depends on the number of loads inside the circuit. So since we only have 3 loads, R1, R2, and R3, so we simply add the value of V1 plus V2 plus V3, and it will give us the total voltage of 10 volts. I hope you guys uh, understand clearly the given discussion. Thank you, and Fox at Bon.